So we're going to continue with our notes, and we're going to be talking about composition of functions. So the composition of function f with function g is written as f of g. It's this little circle. It's like an open circle symbol. And it's defined as f of g is equal to, where you take the f of x function and you plug g of x inside of it. So you evaluate from the inside out, typically. For the domain of f of g, you must consider the domain restrictions on each function. The domain of the composition function will be the most restrictive of all the domains. Now it's important to note that the function composition is not commutative. So f of g of x does not always equal or often equal g of f of x. So given f of x equals x minus 5 and g of x equals x squared, compose and then evaluate the following functions. So the first one they give us is f of g of x. So they want us to find f of g of x. So let me zoom in. So how you rewrite this is f of g of x. Now the easiest way I can explain this to you is whatever the function is that's on the outside, that's the function that you're plugging into. So the function on the outside is f of x, which is 5, or x minus 5, right? So I rewrite the function on the outside, but I leave a blank space for the x, because that's what you're going to be plugging into. Now what you put in that box, or what you plug in, is what's inside, what's on the inside. So what am I plugging into f of x? G of x. We're going to be plugging g of x into f of x, and what is g of x equal to? X squared. So x squared is going to go in for x in this other function. Okay, so you're replacing the x in this function with this function, okay? So f of g of x is equal to x squared minus 5. Now looking at this new function, what do you think the domain of this new function is? Anything restricting about it? No. So the domain is? Negative infinity to positive infinity. Good. So does that make sense how to do f of g of x? Alright, we're going to try the next one. So the next one is g of f of 2. So there's two ways you can do this. You can evaluate f of 2, and then whatever you get here you can plug into g of x. Or you can simply do g of x and then plug in 2, which I'm going to show you. So the function on the outside is x squared. So what am I going to be plugging in to this new function? So you take the function on the outside, you rewrite that function, where you leave an open space for whatever the x value is, okay? So what am I plugging into this x value? F of x? Yep, x minus 5. That's what I'm going to put in. Put it in parentheses. So really, I just found g of f of x. We haven't found g of f of 2 yet. So that's x minus 5 squared. And now, lastly, we have to plug in 2 for x. So that's going to be g of f of 2 is equal to 2 minus 5 squared, which comes out to be 9, right? So really here we just found f of x, then we found f of 2. So just not to confuse you, we didn't get to that step yet. And the domain of this, technically we're looking at the domain of the function before we plug something in, and that would be negative infinity to positive infinity. Now when we evaluate our function at a point, we don't have a set domain anymore because we just evaluated it at one point. So does anybody have any questions about how we did this? Now what you can also have done is you can evaluate f of 2 first. So f of 2 would be negative 3 because you plug in 2 minus 5, which would be negative 3, and then plug negative 3 into g of x. So you can do it that way as well. You can plug in, you can do f of 2 and then take g of whatever that is. And the last one is g of a. So g of a, we're going to take the g of x function, which is x squared, right? So we have x squared, but I'm leaving the x blank. Now what's going to go inside of that? We're going to find g of x first before we find g of a. So we're going to put g of x inside of g of x. So what's going to go in here? X squared. And what is x squared to the second power? X to the fourth, right? And then, lastly, I have to plug in what value for x? A. So we have a to the fourth power. Now, the domain of the function before we evaluated it would be negative infinity to positive infinity. Record yet? So now we're going to do a composition of functions word problem. You have a coupon good for $5 off the price of any large pizza. Let's call the pizza X. And you also get a 10% off discount on the pizza if you show your student ID. Justify whether it would be better to apply the coupon before or after the discount. So, let's call the coupon, let's make a function for this. So, the value of the pizza after you apply the coupon would be x minus what? 5. Because the price of the pizza would be $5 less than what it was originally, right? If we apply a coupon for $5. Now, the next one we'll call D. We'll call D of x the discount on the pizza. I can't draw a straight line today, but D of x is equal to, if you take 10% off the price of your pizza, what percent of the pizza are you paying for now? 90%. Everybody see where I got the 90% from? So, now the price of your pizza now after the discount is 90% of x, which is 0.9 times x. So you've got to convert your percent to a decimal. Everybody understand where that all came from? So, C of x represents the cost of the pizza after the $5 coupon, and D of x represents the cost of the pizza after a 10% off discount. So it says justify whether it would be better to apply the coupon before or after the discount. So let's say that we do C of D of x. So we have to compose these two functions. So we applied the discount and then we do the coupon basically. So you take C of x and you replace the x with what? 0.9x. So C of D of x is equal to 0.9 x minus 5. So this is where you did the 10% off, and then you applied the coupon. Okay, 10% off, then you did the coupon. So this is discount, then coupon. So let's say we do coupon and then discount. So coupon and then discount will be D of C of x. So coupon and then discount. Because it's always work inside out. So you take the outside function, and I'm going to replace my x with what? Of the outside function. What am I plugging into it? X minus 5. And what can I do to solve this, basically, to simplify it? I can use the, what do we call that? Distributive property, yeah. So it's 0.9x, and then what's 90% of 5? 0.9 times 5? Anyone? It's 4.5, yeah. 4.5. So $4.50 basically. So these are our two, this is when you apply the coupon, then discount. Okay. So if you apply the discount, the 90, the 10% off, and then you take away the coupon, this would be the price of your pizza. If you apply the coupon and then the discount, this is your pizza. So basically you get the 10% off either way, you get 10% off and then you save $4.50, or you can get 10% off and then get $5 off additionally. Which one would you pick? Yeah, the bottom one. This one's a better deal, right? Because you save 50 more cents. You save 50 more cents because this you get an additional $4.50 off. This one you get $5 off after the 10%. You guys all see the difference there between the two? Alright, so let's do one more word problem together. Kohl's is having a big sale for the upcoming holiday season. Each item is on sale for 30% off, and then an additional 10% off is taken off the sale price. Let X represent the price of an item and determine if taking the 30% discount first or second is a better deal. So, let's call the first discount, we'll call it D of X still. D of X. So the 30% off sale, D of X. So if your item is 30% off, what percent of the item are you still going to be paying for? 70%. So 0.7x will be the price of your item. And then the additional, we'll call it A of X, is equal to, additional is 10% off. So if you take 10% off your item, what percent of the item are you still paying for? 90%, so 0.9. Now we want to see if it's better to take off the 30% first or second. So we're going to do D of A of X, which is going to be, we take the D of X function, and where it's X, we're going to plug in our other function. Okay, so we're plugging this function into this function where the X value exists. I can just multiply, and I get D of A of X is equal to 0.63x. So basically that's a 37% off. Now we need to do it the other way around. So we need to do A of D of X. So that's going to be the A of X function, and in its X we're going to be plugging in the D of X function. So that's going to be A of D of X is equal to 6.63x. So, does it matter which coupon they apply first? No. You're going to get the same results either way, so it doesn't matter. Now, can anybody explain to me why the last situation it did matter which coupon came first, but this one it doesn't matter? What was the difference between those two problems? Yeah.
The first one we're subtracting.
Good. Hang on, we'll wait for the bell. Yeah, so the first one, we were basically subtracting something away. This one is just multiplying by a fraction, right? So multiplication is what kind of property? Commutative. Subtraction is not commutative. So see how commutative properties, order doesn't matter. When you're involving non-commutative properties like subtraction, things like that, it does affect it, okay? So just keep that in mind. So that's that. So here I'm just going to go over some homework problems. Number 7. Number 7 says 5 times f over g. And this problem gives us f of x to be 2x plus 5. And the other function is g of x equals x squared minus 3x plus 2. So we're finding 5f over g. So I'm going to plug in, so it's 5 times 2x plus 5 over g of x, which is x squared minus 3x plus 2. So in this problem, you could simplify it, but we need to identify the domain first when you have a fraction. So we have to set our denominator equal to what? 0. So we're going to set our denominator equal to 0. And how would I solve for x when it looks like this? We have to factor it, right? So what are factors of positive 2 that add up to negative 3? Good, negative 1 and negative 2. So that means x is equal, or x minus 1 equals 0, and x minus 2 is equal to 0. I add 1 to both sides. I add 2 to both sides. And I get x equals 1 and x equals 2. So these are what we call our exclusions from the domain. So the domain is going to be all real numbers, except for when x is 1 and when x is 2. And then from here, all you have to do to simplify this, you can just distribute the numerator. And that gives you 10x plus 25 over x squared minus 3x plus 2. And that's all you can really do with it. Can't do anything else, can't cancel anything out. So now we're going to do number 12 from the assignment. So g of x goes on top, f of x goes on the bottom. So anyways, back to number 12. We have a fraction divided by something, right? So you guys remember keep, change, flip, the old rule that you learned about a couple years ago? So you're going to keep the first fraction. We're going to multiply by the other fraction flipped. So we put it over 1. So the reciprocal of the second fraction, like this. Well, we multiply that and we get 1 over, and you can use the distributive property here. We get x times 2 minus x, and we distribute the x. And we get 1 over 2x minus x squared. So that's what we end up with as our answer, but we also need to identify our domain. So we need to set this equal to what? 0. We have to set our denominator equal to 0. So once I set it equal to 0, I see that I can factor out the x, right? So this gives me x times 2 minus x is equal to 0. And then I can set both of these each equal to 0, right? So x equals 0 and 2 minus x is equal to 0. And the answer here is 2. So x equals 2 and x equals 0 are our restrictions. Now, you could have also at this stage saw that those were going to be our restrictions. So right here in the green, we have a denominator here and we also have a denominator here. So you could have also set each of those denominators separately equal to 0 and gotten the same results. So your answer for number 12 is this, and these are your restrictions on the domain. So your domain can't have a 0 or a 2.